This is Delphi WebMocks. We're talking about integration testing HTTP clients with WebMocks. I'm Richard Hatherhall from Appercept. I'm an MVP for Delphi and the author of Delphi WebMocks. You may be aware of my other product, Appercept AWS SDK for Delphi, available as a part of a RAD Studio Enterprise subscription. I'm also the author of Chat Health, a messaging platform that powers messaging services offered by the National Health Service in the UK. So let's have a look at what we're going to be talking about. So I'm going to give a brief overview of testing practices, just so we can all understand we're talking about the same things. That's not really the focus of this talk, but just to make sure we're all on the same page. Then testing HTTP interactions. We'll talk about HTTP and what you need to do to test it. We will then have a tour of Delphi WebMocks and its features. I'll give you a demo of Delphi WebMocks, and then we'll have a quick summary of what we've learned today. So straight into testing. So test-driven development is generally how I work, and that's why I built WebMocks, and we'll go into more of that in a bit. But TDD, in its simplest form, is you write a failing test. So you write the tests first before you write any actual real code, and you then write the code, the real code, for your application or the class that you're working on, and you make the test pass. In its simplest form, you don't write any more than you need to just to make that test pass. And then you refactor. So you look at what you've done and you improve the code, and you make sure that the tests keep passing. And then you repeat. You do it all again. And it's a cycle. It's a very short cycle if you're doing it properly, that's constantly giving you feedback, making sure you know that what you're writing is working. And let's have a look at the benefits of testing in TDD. So in theory, you get improved code quality. If you weren't getting something out of testing, it's there's no point in doing it. So one of our biggest gains is improved code quality, early bug detection. So because we're writing tests for the scenarios we use our code in, we should be spotting bugs earlier before they ever make it to production. And you generally write cleaner code. And because you're writing more focused code, more leaner code, the code is generally cleaner. It leads to better design. So when you're writing how you would like to consume some code, how you would like to invoke it up front, you think about the API for that. You think about the interface design of your functions and classes, and how you would naturally like to write the code to call that thing you want, and that encourages modularity. So you think about more about the coding principles like Solid, where the S in Solid is single responsibility principle. And that says that one module of code, or whether a class or something, should be focused on one task, and then your code is more modular, and you'll start to find you're reusing more code. And then because it's a cycle, it generally increases your performance in development. So you reduce debugging time because you're testing things out how you expect them to behave up front, before you actually put them into a real application, and the feedback is, or it should be, instant if you're doing it properly. And because you're getting that instant feedback that says, no, this doesn't work, or yes, this does work, and you fix it there and then, you're focusing on what's next all the time. So it's like, yeah, I've done that, tick, what's next? I write the new test that tells me what I need to do next, and I move forward. We should understand there are some there are also different levels of testing. So the most basic form is unit testing, and unit testing just says you have a unit of code, whatever that unit is. It should be the smallest thing. So you have a unit under test. It should be the smallest testable unit of behavior that you want to test, and it's typically a single class or method. And dependencies should be faked, mocked, stubbed, to isolate features requiring interaction. So you don't want to be testing things beyond the boundaries of the unit you're testing. The more things that are interacting with your unit, the greater the variables are in your testing. You need to try and isolate that so you can control the environment that you're testing in, and then you should know the results exactly of your unit that you're testing. Then above unit testing, the next step up really is integration testing. So this is where you have what would have been unit tested in small isolation, but you now want to test multiple classes. The smaller units, how they combine together and how they interact with each other to get a greater piece of functionality working. So it checks the components, how they work together as a system. And then we're going to talk about HTTP interactions, because there's more to testing than that, but with HTTP interactions, we are talking about integration testing. So let's have a look at what HTTP requests and responses look like. So this is a HTTP message here. It's a request, and we'll break down this. So first, there is a method at the start. So this is a put method. So in HTTP, there are a series of accepted or common verbs, like get if I want to get a document, in this case put if I want to put a document somewhere, there's post, there's patch, there's delete, so all the typical common things that you want to do with documents over the HTTP protocol. They all start with a verb to say what is it I'm intending to do with this request. Then we have a URI, and the or URL to many, and the URI indicates what document that you actually are trying to interact with. So in this case, /document.json, and then we have a protocol version, and the protocol version is. There are multiple versions, but the most common version you are likely to see is HTTP/1.1. Then we have headers, and these are just key value pairs. So everything to the left of the colon is the name of the header. Everything to the right of the colon, excluding the surrounding white space, is the value granted to that. So you can see here that we've got a host of www.example.com, and that typically indicates to the server what website that you're interacting with. And here we're saying that also we've got a content type of application JSON, which is the MIME type of what's going to be posted inside the message body. And we can see there is some very basic JSON as an example there. because we've defined the content type as application JSON, that is what the message body we're attaching is. So then each request, in theory, should get back a response. So this is what a response looks like. Almost identical. A couple of subtle differences, and they're almost entirely on the first line. They pretty much are the first line. And we have the first piece of data that comes back is the protocol version. And then after that, you have a number. It's typically a 3-digit integer, which is the status code. So every response that comes back has a status code. In this case, it's 200, and we have a textual representation next to it, the status text for that status code, and that is okay. It's the default everything is all right status code that you'll see in a web response, in a HTTP response. For those of you without an encyclopedic knowledge of all of the status codes, there are dozens of websites out there which are handy references for those status codes. I'm sure we all have a number of status codes that are embedded in our brain, like 404 not found and 500 internal server error. They're typically the most common things you see when something goes wrong. And then you've got the headers. Just like when you're posting a request, the response comes back with headers, which are a key value pair again. So this is saying, coming back, the content type is application JSON, and then the message body below it is JSON. And that lets our client know how, the header of content type application JSON lets the client know you can interpret this body as JSON. And that is as simple as HTTP is. Everything you see when people often talk about REST services or going back further, SOAP services and things, they're all this under the hood. They're all HTTP, so when you're testing services, we're not talking generally specifically about testing REST services. We're talking here about HTTP, which encompasses that. So when you're wanting to write tests, you don't have to think I need a testing mechanism specific to REST. The WebMocks will do that for you. We have to think about, when we're integration testing, we need to fake a HTTP service for tests. And this will exercise all the components of your client. So this is why you want to do it, because you can unit test a lot and say, oh, I know when I ask my client code here to do this, I can test that it understands that message in some way. There are typically ways to do that, but sometimes you really want to know that. Sometimes you really want to know that your the web server would have actually got a web request in exactly the form that you intended it. This is why it's good to fake a HTTP service for testing. Another reason why you might want to fake an HTTP service is real services may be unavailable or too expensive. So you could be working in an organization with multiple teams working on different parts of a platform or product. You might have received a spec for a web service that you're going to be working on, but you haven't got the implemented web service yet. Maybe it's months away from actually being deployed. I would hope not, but let's just say, I would say it's not entirely uncommon that things can take months or an undetermined amount of time. So it might be that they're going to be next week, but by next week priorities in the company may be changed and they reordered something to push it back another month or two. But that's going to block you in your team writing the client. So sometimes you have a spec, but you don't you don't have a service to test against. Another thing is third-party services may be charged for or throttled. So if you're testing against a cloud service, often each request to a cloud service has a cost associated with it. Your account is going to be charged for those requests, and sometimes they're throttled as well, because sometimes to keep cloud services performing nicely with low latency, they will throttle each client to say, hold on, you are requesting too many of these things in too short a period of time. So you should back off a bit and then come back later and we'll look at your requests later. So if they're implementing throttling like that and you're running a test suite on your machine and you're potentially pushing that up to a CI/CD service that's then building and executing your tests on a machine every time a new piece of code is integrated into the into the trunk, then you're triggering new tests that get fired off. You might overwhelm, and you might not even realize it because it's not happening on your machine. You might overwhelm a service that you're relying on, and one is you might be racking up big bills, and two is you might have test suites that then fail because they've been throttled. So that's another good reason why you would want that. The other thing is responses can be carefully controlled. So if I'm testing against a service and I want to test specific scenarios, like what if this request receives some authorization error, or to say you're not authorized, or maybe there's an error, like how does my client handle a 500 internal server error, or throttling? So you need to build your clients in mind with the idea that they might receive a throttling request, which is 429 too many requests coming back from your servers. It's hard to simulate that against a real service, because sometimes you can. Sometimes you'd have to set up some scenario that's going to generate that error for you, but you can't easily do that, and then there's a whole bunch of prerequisites that you need to do. So that's a good reason to fake your own service, because you can just ask the service to respond how you want it to. So what is our format of testing? We have 3 phases in a test. We have a range. This is make things a particular way. Set up the things you need to do to set up a scenario. So in this case, with testing HTTP, we add in there, we set up a local HTTP server. And then we configure the client under test to point to that local server. Obviously, there's no point in setting up HTTP server if you can't point your code to run against it. So that's what you need to do if you want to test HTTP clients in this fashion. And then you act. So you execute the test. You do the code that's going to make the HTTP request. So that's what you would normally do in a normal test scenario. You arrange, you act, and then you assert, and that is you verify the results of the test. You say, did I get back the results I intended? Or if you're testing error scenarios, did I see the exception I was expecting for this error, or something like that. So let's have a look at doing this with Indy. Indy is the go-to solution for most of us Delphi developers when it comes to building network servers or clients. It's the Swiss Army knife of internet toolkits, and I point out here that this is a DUnit X. Half of the code we are seeing here on this screen is DUnit X boilerplate, and then half of it is Indy boilerplate. So you can see here on the left hand side, you can see I'm testing for the purposes of demonstration here. On line 17, our unit under test here is a THTTP client, which is a part of the systemnet HTTP client unit that is shipped with Delphi. So it's just an example here that how to make HTTP requests. Then we have a server, which is a TID HTTP server, and we're defining here an on-server request event, and in the setup, so over on line 39 on the right hand side, you'll see that we define a static response here, that when a request comes in, no matter what it is, when a request comes in, it's going to respond with a 200 OK, and it's going to respond with the response text of OK. So response null, I should point out, response null isn't really a HTTP spec kind of term. That should really be status code, and again on response text, it should really be status text, as defined in the HTTP spec. And then we're specifying here there's a content type of text plain with a string stream which has the plain text in it, and we've add a flag to say we free the content stream after the request, and that's fine. And then so on the setup block just below it, we instantiate a server and we point the on command get to on server request, and we specify a default port of 8080 here, and we activate the server. And the next block in the teardown, we clean up after ourselves, because we should behave well like that. So we free the server. And then if we have a look at the procedure on line 59, test get. So this is actually one of the test methods. So this is the crux of our test. We are saying we are going to create a client, so the THTTP client, and we are going to ask the client to get localhost 8080, and we're going to store the response of that in our response variable. And then we assert that the value we expected to come back is in the content as string from the response. So all of this is fine, it works. This will work for testing a HTTP client, but there's a number of issues here. And if I move on to the next slide, we'll see. So there's lots of boilerplates. So on top of the standard DUnit X, there's huge amounts of boilerplate. And then we've got terminology mix-up. So those of us who are used to working with HTTP, things like response north versus status code, these are things that, okay, we can remember them after a bit of repetitive coding. These things will bed in, but it would be nice if the terms we were using aligned with how we talk about HTTP. There's another thing here, which is response logic is disconnected from the test. So testing different scenarios will require multiple on-command get or on-command other implementations. And I should point out that on-command get is for HTTP GET requests, and any other verbs are handled by the on-command other. So there's a slight disconnect here as well, that you've got to implement multiple events for dealing with these things. And you can, I mean, like if I briefly take you back to the code, I could say we could define on the left-hand pane here, where I've defined client and server, I could define a bunch of variables there that we could manipulate. That in the test we would see that we could manipulate them, and they would then somehow change the response that comes back in the on-server request. And that would work, but the other issue I've got here is the test get. It doesn't really describe what the intentions are of our test. So what I what I mean by that is if I want to test a client and I understand something that I want a web server on a specific thing to be on a specific definition of an endpoint, so it's got to respond a specific way to a post on this URL. The code to do that, I feel as someone who writes tests a lot, I feel that the test code should be descriptive about what I want, and that's a problem with the code we've got with Indy here. And then there's Indy specific knowledge required. You need to know quite a bit about the classes and the internals of the TID HTTP server to manipulate what it's doing. There are some gotchas in there as well that I won't go into here, but certain scenarios that Indy is being super helpful for, like handling certain scenarios, but when you're trying to test things, sometimes they actually get in the way. And then I've run into the problems in the past, like where are the Indy docs? There was a period, I don't know what the case is at the moment, but there was a period where the Indy docs were offline or moved, and trying to work out where the docs were was mildly challenging at one point. And this isn't, I'm not having a go at Indy. I really like Indy, like many of us Delphi developers. It's our go-to choice for these things. But Indy is not geared up. It's not optimized for writing tests. It's optimized for what it does, which is RAD style network components. And the other problem here we've got is it's slow test development. So because and this is bad for TDD, which requires those fast loopback cycles, because you have this disconnect between the code of your test and these events that you have to write in a different part of your unit. There's more effort to move around and to then come up with strategies about how you would share some of that setup code amongst tests. It's all a problem for TDD, and if you do as I described, where you set up some shared variables, some shared function fields to manipulate your test, and then you have common tests running on them, then you're going to potentially run into bugs because you're using shared fields, and they might not always be want. You might think, oh, I now need to manipulate this and change the way it works, and then you end up breaking tests for other tests that rely on them, and then you have to start refactoring those tests. They're all things that sort of they conspire to slow you down. So we don't want that. So let's have a look at how we deal with this with WebMocks. So here's the WebMocks way. It looks largely the same, except for we don't have much setup code in terms of the HTTP server like we do with the Indie way. So we have beyond DUnitX, beyond the DUnitX code, there are 4 lines here that we do, which are WebMocks setup, WebMocks boilerplate. The rest of it is all in the test get, and as you can see, test get on the right hand side at line 38, we have a response just like we had the response before, and we describe, using our WebMock, we describe what we want to do. We're saying webmock.stubRequest ** to respond with body hello world, and that is doing exactly the same thing pretty much as the Indie way was doing. And then when we get on line 46 on the L response equals client.get, we notice we, rather than having to remember there's a static local host and what port it's on, we ask the WebMock to give us a URL for, in this case, the index document. So that will give us back a URL for how the WebMock is configured. And then below line 48, the assertion, it is exactly the same as it was before. We are testing the iHTTP response, that it had the content we were expecting as a string. And that should pass. Just the same as the Indie one would. So let's have a look at the boilerplate. And so we boil this down a little bit. And the first thing we do is we add WebMock to the uses clause. You can see on line 7 on the code there. That's pretty standard. We add a private field for twebmock. So in this case on line 12 we've added a WebMock field for twebmock. And then we initialize twebmock in the setup. So down on line 24, webmock equals twebmock.create. And we, in the teardown, we free that WebMock, making sure that we've cleaned up after ourselves. So stubbing requests. What can we do with stubbing requests? So this is a typical stub request. So we're expecting a put resource. So we say webmock.stubRequest. And the first parameter is the HTTP method, the verb that we're expecting, in this case put, which, as you can see, matches on the request on the top left. The first verb there is put, so that's what we're expecting to match. And in the stub request, the second argument there /resource marries up with the URI on the request. So that will match, and if it matches, the default behavior when you stub a request is to return the response HTTP 1.1 200 OK, and that response there on the left is exactly what you should be getting back with WebMocks. That's if you don't change the behavior. So let's have a look how we can customize the response. So as before, put resource. We are matching put resource, webmock.stubRequest put resource. And here we're changing the HTTP status code to respond 201. So on the right hand side there you can see the first 2 lines, to respond 201. But what if we don't have one of those encyclopedic brains that knows all of the HTTP status codes? Well, if you add to your uses clause the webmock.response status, you can then refer to the status codes as twebmock response status.created. So 201 is created, and if you specify it as twebmock response status created, that will do exactly the same thing. And as you can see on the left hand side, the response on the bottom, you get back 201 created. So let's look at how you would customize the body. So if we want to get a document, as we saw in the first example, you can say to respond. So this is a fluent interface. So a stub request dot to respond dot with body, and then we give the content of the body. And we can see here the response content on the left hand side coming back as text plain with the content length of 13. And the thing you should note here is that with body, by default, if you just give it text like this, it will respond back with text plain by default, being the content type. If you give it something else, you need to specify what that is. So if we want to respond with JSON as a body, so here's an example: get document JSON, and on the WebMock we're saying webmock.stubRequest get document.json to respond with body, and we can see there we've just got some empty curly braces, and the second argument of with body is a content type, in this case application/JSON. And you can see on the response on the left hand side, it's returned 200 OK. By the way, I should point out that we haven't been specifying a change to the status code, so the default is always 200 OK unless you change it. And it's come back here with the content type as specified, and the content. So what about more complex bodies? Things you can't just easily represent in a line or so of code. We can provide fixture files. So in this case here, we can specify with body file, and you should specify a path to a fixture file that has the content you want to respond. And as you can see in the example here, I've just used the same content response, but it would be coming from a JSON file. Notice I've not specified here the content type, and the reason for that is, and the reason it has set application JSON is because there is some basic MIME type detection that goes on inside WebMocks. It's actually, to be honest, it's actually leaning on features of Indy, where it's detecting the MIME type of the extension, and it knows that would be application JSON. If it doesn't know what MIME type it is, it's going to return the standard application/octet stream that you would get for any unknown binary content. So then let's look at how we'd customize the response headers. And if we want to add a header into the response, we say, so after the to respond. So it's worth pointing out here, everything after the to respond is a customization of the response. So, and you can chain these together, by the way. So you can chain the with headers and with body. You can chain them together to make complex responses. And here we're adding in the header, my header, with a value of ABC, and as you can see, the response coming back would be 200 OK my header ABC. Then you often need to customize multiple headers, and I should point out again that It's a fluent interface, as I said before, where you can chain these things. So the first way to add multiple headers at the top there is to respond with header my header 1 of ABC, with header my header 2 of XYZ, and that is, in my opinion, the nicest way to add multiple headers in to your response, because it's the most descriptive way. It's written right there in your code in the cleanest way, so you can just instantly see what the response is going to be. There are times, though, however, that you might have quite a lot of headers that you want to respond back in certain scenarios, and you might want to load those in a common area, or to be shared amongst tests, or have some loading mechanism to help you across tests. And so there is a function called .with headers, which will accept a string list, and you can build up header values using headers.values, and you can just pass that to your .with headers, and those headers would be set exactly the same. So the code at the top is exactly the same as the code at the bottom, one using the Fluent interface, one using predefined headers. So then we have the ability to dynamically respond. So this is where you take an anonymous method to provide dynamic responses. You customize the response through a simple builder interface, and the anonymous method provides access to request data for customized responses. And this is what it looks like. So you can see that the WebMock stub request is the same, but instead of just saying to respond, you say to respond with, and then you define inside that an anonymous method which has a procedure with two arguments: a request, which is an iWebMock HTTP request, and a response, which is an iWebMock response builder. And the what you do here is you just say a response .with status, and here we're specifying a non-existent or really obscure status of 555, and I'm passing a body of dynamic response. So the response builder is identical to the response builder that you would be interacting with when you are defining the static response. But here the benefits are you can actually customize this response on the fly. So you could be you could have some dynamic data. Maybe you're responding different in each time. Every time a request is made, maybe you want to respond with, I don't know, the count of requests that have been made or something like that. You can do that here, where you can't do that in the static responses. So let's have a look then at matching requests. So we can customize the response as much as we like, as you've seen, and now we need to think about how to focus our tests, how to focus the matching of the requests, because and one of the reasons you would want to do this is, rather than a catch-all request like a stub request ***, which is a wildcard match anything request. Sometimes you've got clients that are going to make multiple requests in a specific pattern, and you need to respond at the right time to the right thing. So you can stub multiple requests, and you are going to want to match those responses to the requests appropriately. So here we have a HTTP method post. So you can do the WebMock stub request post / would match this, or you can do the wildcard match, which is webmock.stubrequest / and that matches the same post / request that we can see here. Of course, like I say, the wildcard will match all of the HTTP verbs there, so it's not always the thing you want to do. I would say be as focused as you need to be. And then let's have a look at the URI. So matching by URI is pretty much the same. So at the top there on the right, you can see stub request get /document /hello.html will match that request on the left there. But you can do that with wildcard as well. But again, wildcard is going to match everything. So maybe you want to say, I want to give this response to any document, not just hello.html. I want to give a certain response to any document, and that's where regular expressions come in. So you can say on the third example there, you can say WebMocks stub request get with passing in a regular expression, t-regex.create, and in this case /document with a .* on the end to say any characters after the /document /. And that will match that hello.html as well, because it was prefixed with /document /. It's worth noting as well, if you do this, you're going to want to include the system.regularExpressions unit in your test unit to be able to use t-regex. The next thing you want to do is, because URIs can have query parameters, and these are while they are a part of the URI, it's a special case, let's say, because you have something like this where we say get search question term equals hello. So everything after that question mark is the start of your query parameters, and this only has one query parameter on it, which is term equals hello. So that is a parameter named term with a value of hello. If you've got multiple parameters, they will be separated with ampersand characters. And we can match query parameters easily with query param. So in this case, we say WebMocks stub request **. So we don't care what the request is, but we do care that it has a query param named term with a value of hello. Now, if you don't care about the value, you just want to know that the term query param was present, you could use a wildcard. So you can say with query param term *, and that says I'm going to respond to this as long as term was present. I don't care what value it was actually set to. Then you can use regular expressions again. So in this example, the third example here, where we give it a regular expression, in this case we're just saying we want one or more characters. So term has to be a value that's one or more characters, A to Z, upper or lowercase, 0 to 9. So that would, all three of these things here would match and respond with 200 OK. The next is by header. So we want to be able to match when headers, specific headers come in, and we can do that very much the same. So with header accept video MP4. We can do wildcard accept *. We can do with header accept a regular expression, as we can see here. I've created there's a regex there that basically says anything that's prefixed with video and has letters and numbers as the second part of the accept header, we match. And then we've got with headers again. So we can do matches by chaining with header, for example. We can supply with headers as a string list, and that will help you match those headers. We can request match bodies. So if we say I want to stub a request ** with body hello world, if the content in this case matches the body exactly of hello world, it will give back a 200 OK. If it's if you want to only match a partial body, then you can use regular expressions to match that body. In this case, we're just saying anything that starts with hello, comma, and then a bunch of characters and then terminated with an exclamation mark, that's going to match. But bodies are interesting because bodies can be complex data types. So the most common in web interactions typically is, or certainly in web, web applications, not API applications, would be form data. So form data is like this. So it's exactly the same format as your URL or URI query parameters, but the content instead is going into the body, not in the URI. So the content type is application x -www -form-URL encoded, and then the values username equals superadmin, ampersand to separate another value, password equals god. So super secure username and superadmin username and password here, and we can use a handy helper called with form data. So we can say stub request with form data username superadmin with form data password *. You can see I'm using there the wildcard for matching the password, or you can stub the request with the same thing effectively. The second example here would be doing it with a regular expression. And then we can do the same thing with JSON. So we've got this JSON payload here, it comes in, and we can say we're going to stub this request with JSON where display name should be *. So we're wildcard matching the display name. We must have a display name, but we don't care what the actual value is. And notice here we're using JSON path. So to get the nested values of preferences color scheme, the color scheme value within preferences hash, we say preferences.color scheme, and we are testing here for a specific value, and then I've got a regex here matching the preferences.language. Just as with JSON, we can do exactly the same thing here with XML. So this is effectively the same data structure, but submitted in XML, and we can use the .with XML matches to do pretty much exactly the same thing we just did with JSON, but instead of using JSON path, we use XPath format to define where the values we're looking for are. So this first one /profile/display name is how we get to Howard Hughes as the display name. We've also we always respond. WebMocks always responds, but what happens when nothing matches? So this case, delete document, where we're stubbing the request for get document, it doesn't match. So we respond back a 501 not implemented. So we always respond back with something. But it's you should keep an eye out for the 501 not implemented responses, because that means your matching is your request for what you're expecting is not quite what it should be. So then let's have a look at dynamic matching. Just like dynamic responses, we have an anonymous method which allows us to do matching. It allows any custom logic to match a request, and you just return true to match it, and you return false to ignore it. So if you return true, it's going to generate a response. If you return false, it's not going to, or it will generate the normal not implemented response. And this is what it looks like. So stub request, instead of the string parameters, we pass it this function with a request argument, which is an WebMock HTTP request, and it returns a boolean, and you just say result equals true if you want it to match. So you can inspect the content of the request argument there, and if you like what you see and you want to match against it, then you just return true. Otherwise, return false, or do nothing, and it will. And false is the default behavior. Then a key important thing about WebMocks is verifying requests. So if get/ comes in, and we want to know that get/ was actually performed, we can do this. So we stub the request get/, and then we do something, in this case get index on my client, and we're expecting that procedure on my client is going to make a request, a HTTP request of our server, which is going to be a get to the URI /. So we can write the assertion as webmock.assert.request get/ was requested. So here you can see we're using this WebMock syntax to be very descriptive, not only about how we want to match and respond to requests, we're also descriptively writing our assertion, so we know exactly what we expected. And we provide shorthands for all of the common HTTP verbs, or the most common HTTP verbs. As you can see, webmock.assert.delete, and then you only pass it the URI that you're expecting. And then we've got get, we've got head, we've got patch, we've got post, and we've got put. It just helps to clean up the syntax as you're writing it. And we can also verify the requests by inspecting history. So all requests performed are logged. Inspect the history to find out more. And its history is a list of WebMock HTTP request instances, and it provides access to the HTTP method, URI, HTTP version, the headers, and the body. And you can inspect them and work out whether things happened the way you expected them to. And when you need to, you can reset the history. So if you're doing multiple runs of a test, if your test is to say how things behave on repeated calls, for example, and you want to clean up your history so you can make new assertions, you can just call WebMock reset history between calls, and that will just clean up your history. And because it's the history that the webmock.assert builds upon, you don't necessarily need to directly interact with the history yourself, but it's useful to know that reset history is there even for the webmock.assert calls. And then it's worth noting there are negative assertions. So if get/ comes in, we stub the request. What if we want to make sure that a request wasn't made? And in this case, we're saying when we do a my client get index, we aren't expecting. This is a slightly contrived example, by the way, but it's webmock assert request delete / was not requested. So we're saying we're just saying the inverse of it. You could do some of these things without these inverse methods, but it just cleans up the syntax by doing it this way. And then let's have a look at verifying requests with matches. So just as we would expect to do on the stubbing the request side, we can also use those matches the same as we could on the assertion. So we can be very specific and say we expected here webmock.assert put / with query param version 2 with header authorization matching a regex with JSON title updated document was requested. So we're doing a lot here. We're doing a great deal of inspection here of the HTTP messages without doing a huge amount of work. We are just being very descriptive about it. If you wanted to do this in a DUnitX test without WebMocks, all of the things you would have to do to make sure all of that was true would make the test in many ways unviable. How are you going to justify to your boss that you're going to spend ages writing lots of complex code to verify things, whereas WebMocks just lets you just write it out fluently. When working with common patterns within a application, you might want to consider how to organize stubs that you might repetitively use, and we'll use REST here as an example. So here's a brief recipe for REST, and we'll just quickly describe what REST is first. It's an opinionated sort of abstraction of HTTP, but ultimately it is just HTTP. So when you create a resource, you are typically making a post request to a resource endpoint. So in this case, / to the index. And if you want to read from a REST endpoint, you do a get / for the index of those of that resource. You do a get / ID for the individual objects that you want to retrieve. If you want to update an object, you use the same as you would for the get resource. You would put or patch a payload to the /ID endpoint, and if you want to delete an object, you would do a delete /ID. So you should consider creating repositories, because this is what it looks like on the right. The WebMock stub request post resources at the top there, with header, content type, application JSON, to respond 201. So 201 is created. So that's typically what you would respond to a post request in a REST endpoint. Then we've got the reading resources, which is actually using a regex to say this resource object, whatever it is, we stub the request get to tregex create /resources / and then any number. And then again we respond with some JSON there, which is what would be expected for fetching an object from a RESTful resource. Again, the read index, very much the same thing. We don't need the regex though, because we are fetching the index, so it's /resources in this case. And there's just an example here with body with resources with an array of resources to be returned. In this case, it's an empty array. And then there's the delete object, which is just virtually the same as the get for reading a resource, but it's looking for a delete. And then the thing at the bottom, and I'll put a note here, place this at the end. And the real reason for that is programmer laziness. We don't want to repeat that line for both a patch and a put in case you are flexible in accepting which methods you use. It's common in REST to use patch and put interchangeably. Some people might disagree with that, but that is the reality of REST resources. So we use a wildcard on the method. Now, if we place this higher up, above the delete or the get resource, the read resource request, then it would be confused, and it would be this response that would match above those things, because the stubs are evaluated in the order that they're defined. So that's why in this case, because the response is going to be the same whether it's a pat or a butch, we're just putting it at the bottom there, so we can then use the star to show to match that. Okay, so let's quickly have a look at failures. So you need to have a recipe for failures. HTTP clients should be able to handle failures, test them. And as an example, your resource failures are going to be things like redirections. If that's things in the 300 area, 301 and so on, 302 and whatever. And then you've got the one we all know. I think everyone in the street, whether they work in computers or not, knows a 404 not found. We've all seen one. You should consider authentication and authorization failures. So not signed in, 401 unauthorized, not authorized, 403 forbidden. And then you should consider service failures, 500 internal server errors, and throttling responses, which is 429 too many requests typically. And you can see here I've got a little example where we're going to do a dynamic response, which allows you to test a client. So the first two requests that it receives are going to be too many requests, with status too many requests. But the third request is going to be responded to with an OK. And if you have something defined like this, you can test your retry behavior, because we shouldn't just be failing straight off on like 429 too many requests. Really, if we can, within reason, we should probably be retrying those to make our applications more robust. So just give it a bit of back off time, say, like maybe wait a second or two, and then try it again. And maybe your policy is if it fails, then maybe you pause for a few more seconds, and then slightly longer, and then you try again. And you can help to test that behavior with dynamic responders like this. Okay, so under the hood, WebMocks is an indie server, of course. I told you I like indie. So we wrap an indie HTTP server, and it takes care of all of the indie boilerplate. You don't need any indie knowledge to know how to use WebMocks. And it automatically binds to the next available port above 8080 on initialization. So that means, well, if 8080 is available, it will use it. Otherwise, it will just keep going until it finds a free port. Or you can override it with a constructor. So you can see here twebmock.create 8765. That's going to attempt to bind to that port for you. And because your WebMock, your client isn't going to know what port your WebMock is configured for, make use of the webmock.url for, which will give you a URL for the configured WebMock. There are a few things we should consider about WebMocks. It can't help you to test SSL or TLS only clients. And that's because it doesn't terminate SSL or TLS. That would require a level of complexity greater than I thought of real value in WebMocks. There are other ways these things can be tested. Your clients need to be able to override the endpoint of where your client is going to be able to test it with WebMocks, and testing it with HTTP should be good enough in your tests. But then obviously most clients these days work HTTPS by default when talking to real world servers. So you need to have a mechanism for testing that. It's just not WebMocks. The other thing is it can't help you to test client exceptions. And what I mean by that is this code on the right that I'm showing you here, don't try this. There's no point. It will just return you a 500 internal server error, because all that's going to do is raise an exception inside the Indie server. The Indie server is going to catch that and do what the Indie server does and respond with a 500 internal server error because it got an exception that it didn't know what to do with. So if you think you were going to be like super smart and raise an exception in a dynamic responder that your client is going to see, it won't see that. It won't see that exception. So it's just a little gotcha that I thought I should mention to help you get used to what you can and can't achieve with WebMocks. The other thing is tests are expensive. They exercise a lot. They're setting up, every test is going to be setting up a web server, and then it's going to be defining ways to match requests and then ways to respond requests. And maybe you're using lots of fixture files, loading resources off of disk all the time. This is great. It's better than not being able to test these things, but they are expensive. So they are not. They're a complement to good unit tests. They're not a replacement. So you should be doing all of your unit tests that a good developer should be doing anyway. These are the integration tests that give you that extra level of assurance that things that are very hard to test in unit testing, and hopefully. They will make up a part of a greater test suite. Okay, let's jump straight in and have a look at a demo. So here in Delphi, I'm just going to quickly create a new DUnit X project, and I'm just going to leave the default options, except for I'm just going to ask it to create a setup and teardown method for me because I'm lazy. And T my client tests is going to be our fixture test name here, and here it is. I'm just going to quickly save this. So let's have a new folder, my client, and this is going to be tests.myclient. And the project is going to be my client tests. So this is the DUnit X boilerplate that we can see here. I'm just going to quickly switch the layout of my Delphi to my TDD layout. So I customized my layout slightly to help me with working in a TDD flow, and I do this I use the new Delphi 12 split editor feature, so I can see my test unit on one side and my implementation on another side. At the minute it's showing the tests in both because I don't have a unit yet. And I should note that I use Test Insight. So if you don't use Test Insight and you write tests, you should probably consider going and downloading and installing Test Insight. It is a great IDE plugin. It is my one essential IDE plugin that I always install first of all. Okay, let's crack on with the with this test. I should note that I need to enable Test Insight. So if I right click on my project and say Test Insight project, it now means that when I run the project, the results, they don't show in a dialog like a normal D-unit test run. They are fed into Test Insight, and you can see here it says 0 test, 0 passed, 0 failed, 0 skipped, and that's as expected. It's a blank test project at the moment. So let's make first of all, we're going to make this test unit WebMocks enabled. So here's the boilerplate for our WebMock. So there's one line, and then we're going to define a private WebMock WebMock, and that's line 2. And then in the setup we say WebMock equals t WebMock.create, and in the teardown we say WebMock.free, and that is the boilerplate for WebMock. Of course, if you're doing a lot of WebMock integration testing in your test suite, you might consider creating a base class for your tests that would deal with this for you at that level, and then you only have to write it once. Now we are going to bring in the unit that we're going to test. So my client, that doesn't exist, so I'm going to make it exist, make the tests, or make the project compile again, and my client, and again that should now compile and run. If we then come and set up our client, my client, now that won't pass anymore because we've got a red squiggly there. So we come over into our test unit and we say type my client, and this is going to be a class, and that should be enough again to make this this compile. But in our setup we should probably set this up here. So client equals my client dot create, but we're going to need to pass in an argument here which is going to be the API base for our client. So we're going to say webmock.url4, and we'll just say it's the root of our webmock that is going to be that base for the URL. And we should also remember here in the teardown to free our test. And now let's make sure that our my client has a constructor that actually allows this to compile. So let's have a public constructor create, and we're going to say it's const API base is a string, and we can say, so this is going to be inherited create, and we're going to now say f API base equals a API base. Now we need to define what f API base is, so it's going to be a private field. F API base is going to be a string, and again that should now, once again, that should pass, or should at least compile and run. So now we can actually start writing a test about some functionality that we want to exist. So let's define a test, and how I usually define my tests is, or how I name my tests is, the first part is going to be what I'm testing. So I'm going to test a procedure called get Carter, and then I put an underscore, and then I put a precondition. Now in this case there's no preconditions, so I'm going to say always. It's always going to do. And what is it going to do? I put an underscore and then I describe what it's going to do, and we're going to say makes request. So let's complete that. So here's another thing I often do. If I'm not exactly sure where I'm going with the setup, I start with the assertion. So I go here and say, actually, so webmock.assert .get Carter .was requested. Okay, so let's just run that and let's just see what happens. We've not done anything, but we can now see down here in the test insight we get the failure message, expected to find request matching get Carter. Okay, so that's useful. So there was no request, but that's no surprise because we haven't actually done anything here. So what we want to do is we want to say, how would we invoke this? It's going to just be client.get Carter. This is going to be really simple. It's as easy as that. That won't pass now. We've got red squigglies. So we go over here and we can then just say, okay, so procedure get Carter, and let's define this. So we're going to need something here. This will execute now, but it's still going to fail because it's not doing anything. So I'm going to come up here and say we're going to need an F client, and it's going to be a HTTP client, and that means we're going to need uses system.net.http client, and we're going to need to initialize that. So in our create here we can say F client equals thttp client.create. Now if we're creating it, we're going to need to destroy it, so let's add a destructor to tidy that up. So destroy, and we override that, and we then say F client equals dot free. We're doing the free. So that should now give us a client to work with, and we can just say here f client dot get, and we are going to use the F API base that we initialized the client with, and we're then going to just attach onto it here the endpoint that we want to talk to, and we're going to say get Carter. So if we now compile and execute our test again, we can now see our test has succeeded, and that says my client tests get Carter always makes request has passed. And we can it's worth pointing out here that I haven't actually stubbed this request in the WebMock. And that's fine. If all you're doing is making an assertion that something was requested, you don't necessarily need to stub it unless the behavior of your client needs it. We've not set any behavior here that needs a specific response. All we've said is when you call get Carter, get/Carter is going to have happened. As we develop this further in more iterations, you're probably going to need to come in here and then actually do the webmock.stub request get Carter, and that way that way you know that you're going to get the 200 back. But because our client doesn't actually rely on any particular status or anything, so it doesn't matter for this case. So that's a quick iteration on creating a client with a function that calls a web request and tests it using WebMocks. Okay, so let's quickly run over what it is we have hopefully learned. So WebMocks allows stubbing and mocking of HTTP requests using a simple, fluent interface. And we can see how that helps us. It's designed with syntax aligned with HTTP terms, so we can describe exactly the scenario that we're testing right in the test, and we can even use that that same syntax to actually assert the things with that same fluent interface. It allows complex matching and responses through anonymous methods. So you can do all sorts of crazy things that I haven't even thought about by just adding a couple of anonymous methods. So they're very powerful for you. So do test your HTTP interactions. You know, we've made it easy with WebMocks, so I hope you see some real benefits in your testing practices using WebMocks, and I hope you find that your HTTP clients as a result are more robust as a result. It's not a replacement for testing against real services, so you will need to test against those real services. Real world services do behave, they often do behave different to whatever you imagined in a test environment. So WebMocks will get you a lot of the way without touching a real service, but you will need to go and verify what you imagined in your test suite to actually be true in the real world. It's free, it's open source, so please go and enjoy it. I hope you make good use of it in your daily development. So thank you. That was integration testing with WebMocks. You can get the WebMocks library. You can get it through Get It, by the way. It's available for the current versions of Delphi with Get It. You can also go and install it from the GitHub repository. All the instructions are there for you at this link, github.com/appercept/Delphi-WebMocks. If you want to see more from Appercept and myself, come along to my website, www.appercept.com. If you've got any questions, email me, info@appercept.com. You can tweet or X me at ApperceptHQ. I hope you have found this useful. Thank you.
Well, fantastic presentation. And Richard joins us live in the studio. I'm going to make you appear. Oh, let's see. Let's do that. There you go. That's better.
Hello.
Equal. How's it going?
Good, thanks. How you doing?
I'm doing good. Yeah, I've been chatting away to you in the background, and we've been discussing all sorts of various things. I've got some questions that I'm going to pop up because one of them was hilarious, which is it's not really a question, more of a comment, which was Get Carter, the original Michael Caine version. Everybody spotted your Get Carter reference. You didn't sneak it in and get away with it.
Well, I nearly did. I thought if I hadn't used so much time in the steps in the tutorial part of it, I actually had in mind that I would develop a more involved, complex demo, and it was going to have Get Shorty. It was going to have all kinds of movie references. Like I had ideas for things,
blowing doors off and things like that. That would have to be happening as well, you know. So
yeah, there was all kinds
of classic lines. I'll be back, you know.
Yeah. So unfortunately, I spent more time. As you can see, there's a lot of WebMocks. There's a huge amount of capability in something very small and simple, really.
I managed to let the dog out because he was getting fed up with listening about WebMocks. I think he's got no class personally, but there you go. Patrick also pointed out that his WebMocks is available. You did say this on your video, but available on Get It, Delphinius, and its repository as well. So, and it's
thank you, Patrick. He's obviously a YouTube pro and knows how to put links there.
Twitch, he's always on Twitch. Actually, he's a super guy. Yeah, I mean that's why he's the Spirit of Delphi award winner. He's a real hero. And sometimes unsung hero because he does things quiet in the background and people don't notice quite how engaged with the community is. But he's a real asset to the community, as are you, actually. Funny enough, I don't want to
thank you.
Be too complimentary. It's a very un-British of us, isn't it? So a couple of questions. One of them was, if you were to sum up WebMocks in an elevator pitch, an elevator pitch is where it's Americanism, but I'm technically an American. People get in the elevator or the lift and you've got enough time. Elon Musk is there and he says, what do you do? Explain WebMocks, and you've got till the 25th floor or whatever. What would your elevator pitch be for WebMocks?
Now, I appreciate with WebMocks, and I think testing software in general, it's a hard pitch. It's always a hard pitch, especially for managers. They just see it as lost time. But I would say if your business is network, internet computing, you are talking to web services, things like that, you need to test them. And there's lots of ways to go about testing them, and there are pros and cons about all of them. But this offers the fast middle ground that actually lets you exercise real HTTP requests and actually know that they are being performed. I didn't just off of a whim decide to build WebMocks. WebMocks was actually built years ago now for building my AWS SDK. I built my AWS SDK first. Like I started building it just ad hoc, kind of random kind of thing, and I soon realized, it wasn't very good. I wasn't happy with it, and then I took a moment. I stepped back. I then went and built WebMocks so I could write tests in a nice, clean way, and it propelled my development forward then. So my AWS SDK has thousands of tests testing pretty much every action, every parameter of every action with WebMocks.
Yeah, and if people, I'm going to point in the right direction. There you go, up there. If people scan that QR code that I'm pointing to right now, I'm probably looking at now. That's kind of cool. I'll get like a real YouTuber now. You see. Click on there. But if you scan that QR code, it will take you directly to Richard's website. You can also, and it's important if they didn't see yesterday's session, because sometimes people see these out of step. It's important to know that actually you do the AWS components or API or SDK. I'm not sure how we would describe it, but it's a little bit of both. And allows people to integrate AWS services into their apps really easily. I did one with the space computer that I did where I added a Star Trek computer voice, and people are scanning your QR code. Look, Thank you. I made the space computer speak, and it took me like 5 minutes, and 4 of those minutes were just reading exactly what I needed to do. I mean, I registered the AWS account, which took a lot longer because it is about Amazon.
The admin is always.
Oh my gosh! I mean, I always say to people, and Roger Swan's on next, but I always say to people, C++ is the answer you get when you say, "How can I make computer programming as difficult as possible?" Well, AWS is exactly the thing. How can I make setting up an account as difficult as possible? Because you go to their AWS site and it's like, what do I click on next? I appreciate they have a lot of different things, but wow, it's.
I mean, I think the last time my original sign up for Amazon Web Services was like 15 years ago.
Oh, right. When it was like one website or something.
And I'm pretty sure it was actually much easier. But now, I mean, it's a much more complex beast now than it was.
Jeff Bezos probably hand typed your application into a spreadsheet in those days. Yeah, I mean, I have to say, in my career, AWS has been an important thing, and I think the WebMocks and the AWS, actually, I can see how they join together. And for corporate customers, it's important to understand that with your AWS stuff, Apercept's AWS stuff, it makes it really easy. And if you have tried doing it without your stuff, you'll soon realize quite how difficult it is. Yeah, you can do it the hard way, but the whole point about RAD Studio is rapid application development. That's what RAD stands for. And so why do the hard work with lots of HTTP failure codes and try and do that when someone like you has gone out and put all the effort in and the work in? And I know how much, as I said yesterday, you really craft your components. We have private meetings about your stuff, and I know how much effort you put into it to make sure it's good quality, way beyond what I would ever do. My stuff would just fall over. But
I'm sure you're just saying.
Yeah, I know you're a good programmer, but I always say to everybody, hey, everybody's better than me. I just talk a lot. But that's my skill. But your AWS stuff, if they're using Amazon services, especially things like S3 and Poly and all the other really expanding, burgeoning Amazon services that are out there, you can do magical things. And you and I are actually going to do a series where we're going to show some live coding of using those services as well, because I think as a company, Embarcadero don't promote it enough, and I think they deserve a lot of promotion, and that's something that.
And remember, it's an upsell for Embarcadero because if you're on an enterprise or architect subscription, you already get my components. So
there you go.
As much as I want you all to come along and buy my soon-to-be released commercial versions. It's been available for 2.5-3 years as a part of the subscription, and I often find people don't seem to realize that when I tell them, they're surprised. Yeah,
and I think they also go, oh, does it do this? Yeah, it does. I mean, like I say, the simple thing I did was just making my space computer talk. And it was a bit of fun, but you know what? If I'd have done that, and of course I could change the voice. So I could pick an Amazon voice that sounded just like Margell Barrett, not the same, but similar, and who did the Star Trek computer. For those of you that don't know Star Trek, and you shouldn't really be watching this stream if you don't know Star Trek, but Margell Barrett being the space computer, and so I was able to get it to say things like, Ensign Barker, come to the bridge, and Klingons on the starboard bow, and all those kind of things. But those are just fun things. But it was a few lines of code, and you've shown in other demonstrations like yesterday, translating text, extracting text from images. All of these, as you said, the WebMocks library came into it to make it possible for you to actually write those components and make them so good quality. So there's a kind of synergy between the open source part of it actually feeding into the commercial part of it as well. So when people say, well, why release something as open source? Because A, you're generous and crazy, and B, it gets used by a lot of people, which overall improves the quality of services and benefits everyone. So good stuff. I've got another question, and we've got quite.
And don't forget, I was building on top of open source tools. DUnitX is an open source tool, and
Test Insight
or Test Insight is an open source, but it's free. It's freely available. Stefan Glianke provides it as a download free of charge. So.
Yeah, in fact, there was a question about that. Let me just go to the questions bit. Someone said, and I actually don't know the answer to this. I tried and looked, and I couldn't find out. I'm still sure Stefan would tell us. Is 1.2 still the latest version of Test Insight?
Yeah,
I think it is.
I believe it is. I know it's not very clear on the website, like what version. They don't, when new things, it's not a part of the file name when you download it. But if I remember rightly, it is 1.2 or thereabouts.
Yeah, and in fact,
that's compatible with up to Delphi 12. So.
Yeah, and in fact, Patrick says the same thing as well. All of us met in Amsterdam. Patrick, you and Stefan was there as well. The funny thing was, I had this horrible moment where Stefan is very well known in the community, but he always uses a cartoon avatar. Yeah. So for whatever reason, I don't know why, I'd never actually seen him as a human being. I'd never seen his face. And everyone's like, hi, Ian, come to Amsterdam. We're all greeting each other. And everyone goes, you must, of course, know this person. And I'm looking at it and thinking, I actually don't recognize him. Who is it? And they went, you don't know him? I'm like, oh, God, it's obviously someone very well known.
I had the same thing. As I got out the hotel, I bumped into him, or at the train station, I bumped into him, and someone introduced me. And just as Stefan, though, and I had to squint for a second. I was like, yeah.
Does it look like a cartoon? Yeah. And he just happens to use an avatar all the while that is a cartoon. For those of you that don't know, Stefan Glenke, very, very, very talented developer. He's one of those ones where he gives answers to questions sometimes that, first of all, I didn't understand the question that was asked of him in the first place. And secondly, I definitely didn't understand the answer. And he is really out there in terms of, I mentioned this when we were sitting on stage together in Amsterdam, and he's like, oh, no, you're embarrassing me. I don't deserve it. I'm sorry, but you do deserve it. You are one of those people that, you have to admire their skill. And I admired, you're a skilled developer yourself, and I admire your skills and stuff like that. It takes a developer to understand another developer and have that kind of meeting of minds to understand what is good and what's not good about them. And I've told you to face. I think you're a decent guy. Complete fool, of course, but it was good in Amsterdam as well to meet so many talented developers. And
I hope they're doing it again next year.
I'm going to put so much pressure on Marco G to make it happen. I think in general, everyone was saying that the Delphi Summit was so good that it's got to happen again, no matter what. I think it was a lot of effort by GDK. I was really impressed by how much time they put into it, and we've got plenty of spare time, by the way, so we can chat. Yeah. But I don't know what drain that put on their company resources, because they really pushed the boat out.
Yeah, I know GDK impressed me as a company anyway.
Absolutely,
the way they operate, and I think that event showed, they know what they're doing.
Yeah. And Marco G is, he needs to change his surname to something like Jones or something. But apart from that, it's because I can't say his last name. Marco Geyser. One of them. And he always looks horribly insulted, but he doesn't. I'd rather say Marco G than get it wrong 55 times in a row. So, but I said to them, I was extremely impressed. They are in Brazil, they're in the UK, they're in Holland, and all over the place. And in their Brazilian offices, on the building outside, it says, "We are Delphi." I think that's the exact phrase. And you can't get better than someone that pins their name to the mast like that. And all kudos to them, all respect, because that event, there are lots of good events that get held, but that Delphi Summit was the first time in years where I've gone to, and I've been to a lot of different events, where I've been to an event and it was amazingly vibrant. Everybody there was really pumped by it and said, this is such an awesome event. But the arena that it was held in was that computer games arena. How incredible was that?
Their esports setup and things. I I was actually gutted. Like knowing we were going there, I was excited to go and play some video games and things. But
I never played video
I
games.
didn't. It was non-stop talking for 3 days or whatever it was, or 2 days, 3 days. I can't remember now. It was a blur.
It was a lot of days. Yeah, I think it was just 2 days, but yeah,
2 days. I was there for 3 days. But I showed up with intentions to go play those games, but it was such a blur constantly talking Delphi with so many interested people that I didn't get a chance to. Although I have challenged a number of people, like I think I said to Marco and you, if we do end up going back there, we're going to have a race on one of those racing sims.
Oh dear. I never play computer games ever. I in a career that spans nearly 40 years now, I think overall, I think Patrick says it was a long event as well, because Patrick went and it was a long time. There were a lot of MVPs there and things like that, but it was just regular developers there as well who were able to make it. I know not everybody made it, and I'm sorry to the ones that didn't make it. Yeah. But these events are important. COVID was a horrible time for the world, but now it does seem safer. I'm not going to say 100% safe, because you never know with these things, and some people still say it was a myth, and I'm like, okay, whatever. But my brother-in-law's an ER doctor. He's happy to show you X-rays of people's lungs and go, that's not a myth, But honestly, he said someone with COVID, their lungs look like cracked glass. That's really not good. And I'm guessing that there aren't many diseases that do that to you. So perhaps, a bad apple or a box of cornflakes or something can do it, but I doubt it.
Yeah, but fingers crossed we won't have that again, but or certainly not for a long time.
Well, they said once in a lifetime, but it depends how many lifetimes you live, isn't it? See, the Buddhist karma thing. But I mean, I'm going to Brazil in September, and there's an event in Portugal as well that I think I'm going to. And for someone who's saying I don't really care about traveling, I seem to travel a lot, but these in-person events are important because they do spread the word around about Delphi and enable me to talk to people and get feedback that I can then take back to Embarcadero and say, this is what people are saying. I say it all the time. Email me, and tell me the truth, because I don't want to hear people that say, oh, everything's great, which is fine if it is. But I think if we don't listen to the things that aren't great, then how can we get better? And we should not be scared of people being critical about things. And actually, a lot of people aren't too critical. Everybody wants a product for free, of course, and various things that are ongoing bugs and things like that. But yeah, it's good stuff. Well, look, people need to scan your QR code there to go to your website. I think that's all the questions that we had. Okay. I'm going to say goodbye to you, because I'm going to then introduce a few other sessions as well. But thanks for sticking around. Thanks for the effort that you put in. I know, as someone who records webinars and creates them himself, for every hour that people see, there are hours that go into that. And I know, your slides are so slick. You have these progressions that go through and things like that. I know that doesn't happen it's not by accident. You don't just click and it happens. You've got to put effort into there. So I really appreciate the effort you put in, and we will be streaming, you and I, in the future as well, where I'll probably just sit and keep quiet while I shoot coding. But I do appreciate the effort you put in every time. So thanks for coming.
You're very welcome.
Right, no worries.
I hope people find it interesting. Thank you.
Yeah, I think they do. All right.